Children, this is the third video on SHM. So in this video, we will see the velocity and acceleration in SHM. And one more thing I would like to tell you, children. So all these video series are intended to explain the formulas and concepts in brief. So we will not be solving more examples. So the main intention is to explain the formula and concept. But here and there, I will be explaining a few examples here and there. So I'll take up few examples because some examples, some formulae will be better explained using example. Some concepts will be better explained using, so by taking up some examples. This videos is only to explain the formulae and concepts. Okay, so now we will see velocity in SHM. Suppose a particle is executing SHM, so on a straight line. So this is the path of the oscillation. This is the mean point, and this is the positive extreme point, and this is the negative extreme point. So if the particle is executing SHM, by starting its oscillation from the mean point, and if it is going towards right, then equation of SHM is x is equal to a sin omega t. So in the previous video we have seen. If we differentiate this v with respect to time, if we differentiate this x with respect to time, then we will get velocity. So x is equal to a sin omega t. If we differentiate this, we will get velocity v equal to dx by dt. So a into derivative of sin omega t is cos omega t, and successive differentiation. So when you do successive differentiation or chain rule, then we'll get omega. So that is equal to a omega cos omega t. So this is velocity as a function of time, as a cos graph. Now, suppose you want to express this velocity as a function of x, then how do you get that velocity as a function of x? So this is how we are going to get velocity as a function of x. V is equal to omega root over a square minus x square. How we got that? See children, here in place of cos omega t, we can substitute that. Sin square omega t plus cos square omega t is equal to 1. So cos square omega t is equal to 1 minus sin square omega t. So our cos omega t is equal to root over 1 minus sin square omega t. So in place of this cos omega t, you can substitute that. So if we substitute that, so what you get here? If we substitute in place of cos omega t as our root over 1 minus sin square omega t, omega a into root over 1 minus sin square omega t. Send a inside, so omega root over a square minus a square sin square omega t. So in place of this a square sin square omega t, you can write x square. That's how you got this formula. So once we understand how we got v as a function of t and v as a function of x, you can plot a graph v as a function of x. V as a function of x is an ellipse. So you get an ellipse. So here, this is a omega, the maximum velocity, and this is 0, the minimum velocity. That is at extreme points, the speed is 0, and at mean point, so the speed is maximum, that is a omega. Children, we can substitute x equal to 0. X equal to 0, so what is the speed? V equal to omega root over a square minus 0 square. So v is equal to omega a. So that's how we get speed at mean point. This is the maximum speed. And what is the speed at the extreme points? So substitute, so x is equal to plus or minus a. We substitute x is equal to plus or minus a, then v is equal to omega root over a square minus a square, that equal to 0. So at extreme points the speed is 0, and at mean points the speed is maximum. This is the plot between v and x. You will get ellipse. Even sometimes you will get this graph like this. So the shape will be like this. Okay. So if omega A is greater than A, then you will get a graph like this. If omega A is less than A, then you will get a graph like this. This is the graph between V and X. So now we will see acceleration. How do you get acceleration? Differentiate X twice, then you will get acceleration. So we know V is equal to A sin, so we know X is equal to A sin omega t. X is equal to A sin omega t. Differentiate that with respect to time, you will get velocity V equal to dx by dt equal to A omega cos omega t. So I have done that successive differentiation directly. Then again you differentiate, you will get acceleration, that is d square x divided by dt square, that equal to minus omega square A sin omega t. So that's what I have shown here. So that is acceleration as a function of t. Now, if you want to express acceleration as a function of x, just replace this A sin omega t with x, because x is equal to A sin omega t. So you'll get acceleration as a function of x. So now, we have seen acceleration as a function of t, acceleration as a function of x. Now, how to represent A as a function of x in the graph? So if we represent A as a function of x in the graph, we will get a straight line. So with a negative slope, so y is equal to m minus mx. So that's what is shown here. A straight line passing through origin, and it has negative slope. So we have seen V as a function of x. We have seen A as a function of x. So now this tabular column, this table will give you V values and x values at different positions, at the mean and extreme points. So velocity at the mean point will be omega A, actually plus or minus omega A, and at x equal to A 0, at x equal to minus A 0. Acceleration is 0 at the mean point, and it is maximum at extreme points. The maximum acceleration is omega square A. The maximum acceleration is omega square A. Now, this tabular column will give you the V and x values at mean and extreme points. So then we'll do a simple example. So already I told you that sometimes I'll take up some examples here and there to explain that formula or concept in a better way. So the graph between velocity and of a particle executing SHM and its displacement x is shown in the figure. The time period of oscillation for this SHM will be. Children, just now I have shown you Vx graph. In the Vx graph, at mean point, the speed is maximum, that is equal to A omega. And here, the maximum displacement is A. So based on these graphs, questions will be asked in Neet and JE. So now, compare this here. Here, in place of A omega, we have beta. In place of A, we have alpha. That means omega A is equal to beta, A is equal to alpha. Take the ratio of these two. Omega A divided by A is equal to beta divided by alpha. A will be cancelled. So now omega will get here as beta divided by alpha. Now what is the time period, children? 2 pi divided by omega. So t is equal to 2 pi divided by omega is what here? So beta by alpha. So 2 pi alpha divided by beta. So this is how you can solve. Okay, children, next part we'll see in the next video. So thank you, children.